again, white matter in the CNS is myelinated axons, and they're in bundles called tracts. Okay? And where are most of these tracts? In this structure called the corpus callosum. So it says the corpus callosum is the largest tract and main tract that connects the two hemispheres. So again, it's white matter, it's part of the cerebrum, and what does it have? Again, it tracts, which are myelinated axons, are highways. Okay? A lot on this page, important page. Okay, it says considerable overlap and indistinct boundaries permit a single region of the cortex to exhibit several different functions. So it means it's just, there's a lot of things going on here, but we still can point to a general area and say this is for vision, or this is for control of muscles in your legs, or this is for feeling from your fingers, you know. So, but again, the cortex has a lot of information in it. Right here, it says some aspects of cortical function, which cortical just means in the cortex, such as memory or consciousness, cannot easily be assigned to one region. So consciousness, you have to keep all those neurons awake. So again, it's not just saying, you know, this is what keeps you awake. It's all of it. You know, things like memory. You have memories all throughout your cerebrum. You know, memories of vision are in a different area than memories of smell or taste. So those, some things are very widespread, you know, like those two examples there. It says, with few exceptions, both cerebral hemispheres receive their sensory information from and project motor commands to the opposite sides of the body. Okay, so let me explain this one. First of all, the term we learned, I think, the first day of class. You guys remember that term contralateral? That's kind of an important term. Contralateral just means opposite sides. So, when I move my right hand, okay, what is projecting that motor function? Or in other words, what's making me move my right hand? An area on my left cerebral hemisphere. So that, those neurons, that information is going to cross, and it's going to cross usually it's going to cross in the brainstem area. And we actually can see an area where the fibers are crossing. So again, control is opposite or contralateral. Also, sensory information. If I'm touching something here with my right hand, where is that sensation going to? Or where do I, quote unquote, feel that sensation? In my left cerebral hemisphere. So both sensory and motor are opposite or contralateral. Now, there are going to be a few things that are on the same side, which let me give you a term for that. That's a term called ipsilateral, but those things we'll talk about later. It's nothing to do with motor or sensory in general here, so we'll talk about that later. But again, that's important. Where were we? Okay, so again, opposite sides of the body. So the two hemispheres appear as anatomic mirror images. That means one side you can look at and looks the same as the other. So the gyri and the sulci are all in the same place. That's really what that's saying. What this next word means, hemispheric lateralization. It means even though both sides have the same parts, in a few cases, that particular area or part does something slightly different. So like we might have an area on one side that's for speech. And maybe that same area on the other side is for interpretation of speech. So slightly different functions. So it says, again, the two hemispheres are anatomically mirror images, but sometimes their functions are a little bit different, just a little bit. And again, hemispheric lateralization. And another example of this is you have, most people, some people can work with both hands, what are called ambidextrous, but most people are either right-handed or left-handed, meaning that they have better control or function with one hand than the other. So, if you're right-handed, which most people are, that means that area in your left hemisphere that controls that function is slightly dominant to that same area on the other hemisphere. So, again, if you're right-handed and you couldn't use your right hand, it's hard to, use that. But if you had to, that area would kind of step up, that area over here would kind of step up, and over time you can learn to do that function. People that, even have retrained their brains so that, like, if they've lost arms, let's say, that they can make their toes work almost like fingers. They retrain, especially if you're born that way. If you're born without a particular part that, everybody's used to, you really, as you grow up, you train other areas to do that. Also, people that have strokes,